You're using a 286, don't make me laugh. Your Windows boots up in what, a day and a half?
Another day, another vintage computer follows me home. Greetings, viewers. This is CP666 signing on for what is hopefully going to be a short video about something you have seen already. You may or may not remember this from my Pentium and 286 system exploration. This is the 286 system, of course. And it was marked a surplus because there isn't really much useful about a 286 for anything practical anymore. I mean, really the only thing that we could have used for any systems was the hard drive and the 5 1/4 inch floppy drive. 5 1/4 inch floppy drive didn't seem to work, although I'm not real sure that it's broken. It might just be intermittent. And the hard drive, of course, the only system that used one of these larger size hard drives, is being decommissioned. So, not really of much use to anybody, so the system basically just sat in the back room, awaiting its fate for electronics recycling. Well, I couldn't do that, so I said, hey, I'll take that. And it's been sitting there waiting for me to take it home ever since. That would have been probably about two months ago or so. Shortly after I made the video about it, because I've already made a video about this and I've already discussed pretty much all there is to discuss about it, there's not really, I don't think this is really going to be a long video. I'm either going to go a little bit more in-depth than I did through my narration, point out a couple of things that I've learned after the fact, and we'll fire it up and have a little bit of a demonstration, more of a demo than we had previously. Wow, it's only about 7:30 and I'm already stumbling over my words. That really is not good. This case might be familiar to a couple people, not just because you've watched that video. UXW Bill made a video some years back of an AM386 DX40 based system that is in this exact same case. Of course, the difference being that this one has a sticker on it for some system builder or another that I assume is probably no longer in business. I have no idea how you're supposed to pronounce that. MICATA, I have no idea. But as far as PC hardware goes, it's pretty standard stuff. I mean, you got your turbo, you don't have that anymore. That was to slow down the clock speed to more closely match the original IBM PC and the XT. Though on a system like this with a 12 MHz 286, I believe the slow speed was 6 MHz, which was more than the 4.77 of the original PC and the XT. It is definitely very odd to see something as old as a 286 in something as new as this case. Because it's basically a standard, I don't know what you would actually call this. If it would be a mini tower, perhaps? I think it might not be a mini tower. It might be a little bit, slightly bigger than a mini tower, because it's got two 3.5-inch bays. And yes, one of them's empty. I do have the case cover off, so I wanted to show you something. Check out this motherboard. We investigated this slightly in my Corel 386 video, which you may or may not have seen yet. It may or may not even be public yet. But if we go ahead and flip this around, check out this, how absolutely massive this board is. It's not as big as the board that's in the Corel, I will give it that. But it is so big that they had to put a little plastic standoff on the case rather than the motherboard tray, which I believe is removable. Though how you would go about removing such a motherboard tray, I am not sure, because I've never actually done it. It might not be removable at all, having looked at it a little bit further just right now. I don't know. I'd suspect that it is. It looks like it certainly should be, though. I don't see any screws holding it in place. Hold on, I do see what looks like rivets on the back of the case. So, yeah, it's probable that this motherboard tray does not actually come out, which is kind of a bummer. Would have been a real nice, handy feature to have a removable motherboard tray in this thing. One other thing you'll notice is that this thing makes excessive use of these plastic standoffs. That used to be a very common thing in the PC industry. Instead of using actual screws with a metal insert, like systems these days use, they had these little plastic things. Usually those were a way to bypass the need to have screw holes pretty much everywhere on your motherboard tray. Of course, systems like this use them in place of regular standoffs. I don't know how I feel about that. I think they're kind of flimsy, but that is definitely just me. See a little bit of corrosion on this side of the case. Not really sure how that would have happened, but I never noticed that until now. Fortunately, it doesn't seem to affect the operation of the computer. Getting back to the front of the case, I love this red reset button. It just screams power. Anyway, there's a turbo switch beside it. I don't know if it's hooked up backwards on this system, or if this is the way that it was designed, but it's not like most of them. When it's pushed out like this, the system is in turbo mode. When you push it in, and it clicks, the system comes out of turbo mode. Most systems are set up the other way around, where this is turbo, and this is not. So again, I'm not sure if that's hooked up backwards. Maybe I'll investigate, or maybe I'll just completely forget about it. One thing I was also going to point out is this power switch. Most of the time when you see a baby AT form factor system like this, you have a simple push button switch. Other times, you have a side-mounted flip switch. Just almost like powering on some kind of big industrial piece of hardware, which is basically what a computer was back in the day. But this is a very nice touch. I happen to like being able to see whether the system is powered on or powered off just at a glance. With the push buttons, it's kind of hard to do that. Then again, most systems have a power LED on the front. You can just look at that. But who doesn't like a flip switch? I mean, come on. Some of the eagle-eyed may have noted that this drive does not cover up the entire slot in which it really should. That's because this is an oddball compact drive, probably out of a compact portable, considering the number of compact portable peripherals I've seen in the back room where it came from. As a little bit of a sidebar, really would have loved to have that compact portable, but oh well, you can't have everything. It's a very odd setup. See, it looks like a normal 3.5-inch hard drive with this little button right here, but that's not really how it works. I'll go and I'll get a disk here. I'm not going to grab my boot disk because I don't want to wreck my boot disk if this isn't going to work. So I'll grab, let's see, just some other disk. I don't know, here's a self-running demonstration disk. We'll go ahead and put that in place. You can see that's how that works. Now how do you get it out? Push it, then you pull it. Takes a little bit of trial and error. This floppy drive was actually not installed when I made my original video, or at least I don't think it was. It may have been, but I don't think it was. Taking the camcorder off the tripod here for a second, you can see the power supply, which is a fairly standard baby AT job. Then you can see the pinout if you wanted to hook up your own power supply or power switch, which a lot of manufacturers actually did, and I think this one would require you to do. It looks like it uses spade lugs, and you'd plug them into the switch yourself. Which is another common thing that people did. You can see we got a couple of not connected connections there, and all of that mess. How much capacity is this power supply? Well, one may not know just by looking at it. There's no obvious sticker on it that says, hey, I'm a 200 watt power supply, or I'm a 150 watt power supply. There's nothing on the back either. We'll go ahead and have a look at the back of the system here in a second. If you look very carefully here, we've got ratings, and then, ooh, I see something. My camcorder battery is about to die on me, so I'm going to have to make this quick. That doesn't really help. 200 watts. Just like the Corel 386. Okay, plug in the camcorder and flip the machine around so we can have a look at the back here. Just a standard power supply. I'll go ahead and turn on the video light. You might be able to see the fan inside. Just a little bit. Down here, make note of the fact that there is no 9-pin serial connection. You'll also notice this curious looking hole with this bundle of wires coming out. We'll get into that in just a second. box. There's one more thing I would like to show you about this case. Of course, some of you have been at the game for long enough, and maybe even if UXW Bill is watching this video, he knows exactly what it is. He's probably posted it in the video comment section already. Hey, you dum-dum, you forgot to talk about that thing on the front of the case. Anyway, again, we've got two 9-pin serial ports. For some reason, somebody saw fit to install one of them upside down. Did I say 9-pin? I meant 25-pin. There's two 9-pin serial connections right there. I do have an I.O. board that has at least one 9-pin serial port on it. I may grab that I.O. card and try and install it in this system. Then we can see we get 8, yes, really, you get 8 expansion slots. I'd like to see a system with that many made today. Usually you only get 7, if even that, these days. And not even on the mid-towers and the mini-towers. Mini-towers usually give you about 4. Which is kind of ridiculous, if you ask me. Maybe even less than that. Probably, actually, yeah, probably less than that. Anyway, it doesn't really matter. So, superficially, only 2 of them look like they're populated. This one right here has got a parallel port and a game port. Looks like there is something there, and there is. We'll look at that in just a second. And down there, in the last slot, is the video card. This right here is French, basically telling you that there was a seal on this case that was basically equivalent. The seal MICATA is equivalent to the guarantee of this apparatus. It's pretty much a direct translation for that, literal translation of that. Basically talking about the warranty and all that mess. Cut this sticker and your warranty's void, that kind of deal. Turning the system on its side, you can see the impressive mess of cabling going on right here. I don't know who manufactures this motherboard. It does not appear as though there is really any identifiable markings on it anywhere. I mean, there's VLSI chips all over the place. Perhaps it's a VLSI motherboard. I'll have to see what the BIOS post sign-on happens to say about it. But really the only identifiable markings it's got on it is a revision-B.2 right there, and a made in Taiwan ROC, and then that little sticker down there. It could be a PC chips, or as some people call them, PC cheaps motherboard. Really not sure. But it's interesting nonetheless. Then we can see all the slots, all 8 of them. There are 2, I think there are only 2 of them. Yeah, no, there are only 2. 8-bit ISA slots. One of the 16-bit slots here is being taken by an 8-bit card. This is the I.O. board, which controls the game port and the parallel port, and also both of the serial ports. So this one is even less integrated than the Corel 386 is, because at least the Corel 386 had serial on board. This one doesn't have anything. I wonder what it would do if I were to put in another serial port. I don't know. Maybe I'll just replace one of these 25-pin serial ports with a 9-pin. I don't know, but I'm going to do that later on. If we look very carefully down here, we will see, I can move some of these cables out of the way, in a PLC socket we have an AMD 80L286 12/S. So it's a 12 megahertz 286. It's cloned by AMD, of course. If we move even further in here, I believe this slot right here that is unpopulated would actually be for the 287 math coprocessor. Here behind all the mess of front panel wiring, we can see the RAM. Like the Corel 386, it uses DIP chips. That would be individual chips here. I'm not sure what the capacity of each of these chips is. Perhaps it would say on it. I know there's a -8. Maybe that's what they are. I'm not entirely sure. But it looks like there are 4 rows of 9 chips here. And that's pretty much it. It also looks like these could have had 2 different styles of chip installed. It's been a long time since I've seen DIP chip memory, so I'm not really sure all of the details anymore. I used to know all of this stuff back when I had my vintage computer collection, but When I got rid of all of that and got out of all of that mess back in 2007, I don't really remember any of it anymore. It's kind of sad. We have an actual genuine PC speaker, no squeaker can in here. These back here, for some of the youngins, you might not actually know or recognize these. There were cards that actually used to span the whole length of the case, and that's what these were for. These were to provide a little bit of extra stability to cards so they wouldn't sag when you set your system down. Another thing worth noting is that most modern motherboards have, I don't know, 1 or 2 chipset chips. I think it's actually 1 these days because the North Bridge has been folded into the CPU, but this one, oh no, this is back way before the days of integration. We have 1, 2, 3, 4, 5. There's one peeking up down there, and there may even be one more underneath all this mess. I'm not sure. But yeah, 5 logic chips comprising the chipset on this board. Quite a few. Oh yeah, another thing that modern boards have, they have 2 BIOS chips. And they're usually about this size, rather small. One stores the BIOS and one stores a backup copy of it on the off chance that something happens to go wrong with the flashing process, or for one reason or another you have to call it in as a backup and recover from it. Oh no, this one has 3 chips, and they are actually labeled. Up here is even, down here is odd. Again, I forget what all the details on that were. I think it's got something to do with the bits and what it interfaces to. I really can't remember all the details. And here is the keyboard controller, which is also part of the BIOS. There's 3 chips, and they're fairly large. What are those? 24 pins, something like that? Maybe 20? I'm not going to count them. It's quite a fair few pins. And I'm not nearly as much of a twiddle fingers to do that. And this video is already up at 18 minutes, and I haven't really got to the meat and potatoes yet. The one unfortunate thing about these older systems is that they all seem to use these soldered batteries. You can see this one right here has been removed. There's a little bit of corrosion on the board. Doesn't seem to have hurt anything. But the one bad thing that happens with these is people forget about them, which is natural. I mean, people put them away because they don't use them anymore and come back to them several decades later. And those batteries, those little NICATA batteries that were once recharged when the system was plugged in and operating, have gone completely dead, and they've leaked all over the board. And what they do is they eat these traces that you can see that run by wherever the battery is, and they eat components in their path, you know, resistors and tracers and things like that. It's really quite a sad sight. I've never seen, actually no, that is not true. I did find one board, a 486 board, where the battery was positioned over top of some traces going to the keyboard connector, and it ate those traces, and we had a permanent keyboard error, which really put a crimp in my style because I was looking forward to playing around with that 486 DX2 system. Oh well, you can't really have everything. However, the news is not completely dire. If you own a similarly vintage system, 286, 386, 486, even some Pentiums that use those barrel-style nickel-cadmium or even the nickel-metal hydride batteries, or Apple Macintosh computers that happen to use these are not rechargeable. These will explode when they go violently bad. Or they can explode when they go bad. There's a video on B. Bishop PCM's channel. Oh, it would have been centuries ago now. Oh, it was a long time ago. About a Macintosh SE30 that had one of these little batteries in it. And that thing went boom. It made a big mess out of that system. I almost wonder what happened to that. But nevertheless, you need to get that battery out of there. Now, there are 2 ways of doing this. You could pull the motherboard out. You could get your desoldering tools and desolder the battery. Of course, that brings with it some risk. You could inadvertently hit the board with some kind of electrostatic discharge shock, and that's especially dangerous to do here in the wintertime. So you do need to have proper ESD handling regulation compliant surfaces, which this is definitely a member of. I assure you of that. Or you can do what I usually do with these things, and you can just wiggle the battery back and forth until the leads break. Of course, that leaves with you a little bit of a problem. how do you install a replacement battery so you can actually have your CMOS settings retained? That actually matters on some systems. So what do you do about that? Well, it's very simple. On some motherboards, and I believe this one is an example of such, although I don't know where the connector for it would be exactly. Looks like there's a connector down there. A little 4-pin job. That is probably for an outboard battery. Now, there's probably a jumper somewhere on this motherboard as well that has, that you're supposed to remove or switch to tell the system that it's using an outboard battery. The alternative option would be to get a little coin cell holder, or to even just solder some wires where the previous battery was, and add in a, usually it's a 3x AA battery holder. Of course, we're to put something like that so it wouldn't cause damage to the system if those batteries should ever leak. It's a little bit interesting, but I'm sure that if you go that route, you can devise a way. Now, systems with Dallas modules, it might be a little bit more interesting. That's beyond the scope of this video because the system obviously does not have a Dallas clock module. We may investigate that with the Corel 386. We'll go ahead and look once again at the top of the system. We can see the connections for the 5¼ inch floppy drive with its edge card style connector, if I could talk once again. And we look down here, we can see the hard drive. Now, this is rather odd, because you can see one cable here, which is of the edge card style connection, and another cable here on the back, which again is of the edge style card connection, and it's a little bit smaller than the one that we saw previously. Of course, there are also jumpers, which you'll see on a modern drive. Actually, I don't think you see them on serial ATA drives anymore, but it used to be commonplace on the IDE and some of the early serial ATA drives. Now, this is something of a misnomer. A lot of people will call this the MFM or RLL interface. That is not quite true. MFM or RLL refers to the encoding that the drive uses, or the drive is instructed to use, for its platters. And what that really controls is the areal density, or how many tracks you can pack onto the cylindrical disk surface, or circular disk surface. It's not really a cylinder. Well, I guess it kind of is. It does have a little bit of depth to it, by necessity of being three-dimensional. The interface is actually called ST506 or ST412, or, as this drive controller down here calls it, Winchester. I believe Winchester is the original name used to describe this particular interface. It looks like this is actually a Western Digital hard drive controller. Not sure if you can read that. My apologies for it being upside down. I can't actually read that. WD1006V-MM2. There are two controls here, or there's two connections here for drives, and there's this Winchester connection here. I'm actually abusing a 5¼ inch floppy drive connection for this. If you ever find yourself in the same situation, you can do this as well for the 34-pin control cable. That's what this is. This is the control cable, and this is the data cable right here. So this is what sends all the commands to the drive, and this is what gets the data back. I'm oversimplifying a little bit because, again, it's been years since I've really investigated any of the details, so I don't really know them. But if you find yourself in a situation where you're missing the control cable, like I was, you can borrow one of these edge card style connections. Just make sure you do not use the one that's got the twist. You use the B drive end of the cable, because the control cables do not have twists in them. Again, as was commonplace, this hard drive controller also has a floppy controller on it. And yes, I believe this is, in fact, a Western Digital hard drive controller. You can see copyright 1988. There is what I would assume is the primary logic chip, copyright Western Digital 97. 87, I should say. My apologies. But I don't see any further information on this board, and I should probably get this power connector out of the way there. The one thing I'd like to do is I'd like to put a 3½ inch floppy drive in this. Now, I'm not sure where the issue lies. I could not get a 3½ inch floppy drive to work in this system while it was at work. But that could just be a byproduct of the fact that the BIOS is not retaining its date and time settings or any of the other CMOS settings. I know that was a really big problem on some systems, usually, again, those based on a Phoenix BIOS. this one is not. I've seen some AMI systems that did some pretty goofy stuff when their real-time clock battery went bad. Oh, here's something interesting. But you never thought you'd see an Acer branded IC, but there you go, there is one. I believe that's that silver can there is the clock generator for the CPU. And down here, you have the video card. This is an oddity, an 8-bit ISA card. You won't see that very often anymore. This is a Cirrus Logic video chip, and Cirrus Logic was notable, although I don't think this one falls into that category. They were notable for being the first ones to integrate the RAM DAC, and I believe some other components, like these clock generator ICs here, clock generator crystals, I should say, and some of the other components on this board. They were the first ones to integrate that into the video processor. It looks like this board could have been designed to have a 16-bit ISA slot down here, but the designers chose not to put one there. Okay, I think I've done enough blither blather on this. I'm going to go ahead and we'll hook it up and we'll have a little bit of a software demonstration. Oh yeah, I almost forgot that little bundle of wires that you saw at the back of the machine. That's a feature of the case that some cases had, some cases did not. A little redirect for the keyboard. Now, it doesn't really matter for this Model M, which has a fairly long keyboard cable, but it really came in handy, especially when your computer was on the floor and your keyboard was sitting on the desk for keyboards with short cables. So, system is all plugged in, all ready to go. I've already erased it. Well, I low-level formatted the hard drive twice. Low-level formatted the drive, and when you low-level format a hard drive like this, which is not something that you do on modern drives, because a low-level format, I'm going to discuss this a little bit. A low-level format is basically a way to sort of rejuvenate a drive, because it basically writes zeros to all of the sectors. And on a drive like this, which uses, I don't know if you've ever seen them, the orange platters. It's an iron oxide of some kind, I believe. It might actually be iron oxide, you know. But those platters don't hold magnetism very well. So what you get over time is what's called bit rot. And that's why systems like this, if you leave them sitting for years and years and decades and decades and decades, well, you can't start them anymore. They have a rather hard time reading. Temperature is also a problem on these because this drive bases itself around a stepper motor. Now, any modern drive uses what's called a voice coil. That is basically akin to something like a speaker. And a voice coil enables the head stag on the drive to move wherever it wants. With a stepper motor, you can only move in fixed increments. As the temperature raises and lowers, the drive platter will expand and contract. And as such, the position of the tracks, and thus the sectors, will change. And if they change enough, or depending upon the layout of the drive, which is why MFM versus RLL matters, because RLL packs 33, I believe 1/3 more, which is a clumsy way of phrasing it, but 1/3 more tracks onto a drive. You need a very reliable and accurate mechanism in order to make use of that. One of the common things that people did was they would put, say for example, a 20 megabyte MFM drive onto an RLL-based controller, and they would get 30 megabytes out of it. But they would find that there was a lot of reliability issues because the drive didn't have an accurate enough seeking mechanism, the stepper motor didn't have enough increments, and sometimes it would misseek, or you turn the system off and the platters would shrink, and all kinds of mess. Yeah, it was really a fun time dealing with machines way back in the day. Of course, the other thing that you could do was to take an RLL drive and put it on an MFM controller, and you'd have something that was basically bulletproof. Nevertheless, low-level formatting also serves to lay down the track information. A modern drive stores this on a servo off of the platters so it can use the platters for all the capacity, and thus have less platters. On a drive like this, the information is laid down on one of the disk surfaces, as far as I know anyway. That's how some of the early IDE drives worked, at least. Okay, enough blathering. Let's actually fire this thing up, shall we? Again, you'll see I've got this turned off, and turbo mode is on. Also note that hard drives way back when had lights. Here we can see here, floppy drive seek. Eagle 2 VGA from Cirrus Logic. 286 BIOS, copyright 87 AMI. For MBVLSI-168. I guess we now know our motherboard information. 1 meg of RAM. Cmos checksum failure and Cmos display type mismatch. It's thinking we've got a monochrome monitor installed because that's what it defaults to. So we push F1 here. What it should do is boot us into this selection. We can either exit for boot, run the Cmos setup, or run diagnostics. I'm going to run the Cmos setup. And you can see this is what Cmos setup utilities used to look like. Again, just like the Corel 386, the 286 here has a very simple BIOS setup utility by American Megatrends Inc. or AMI. Although it's a little bit more advanced than what the Corel has. I think it might be, no, it'd be about the same date, 1989. You can see, of course, it's gone all the way back to the year 1980. And for some reason, my camcorder is crooked. I better fix that. Well, I can't fix that. That's very annoying. Must be this tripod. So it's gone back to 1980. We have a 1.2 megabyte 5¼ inch floppy drive, which I believe is what that is. It might be 360K, but I think it's a 1.2. I don't know if it actually says on it what it is. It just says compact spares. That's pretty much it. It's a Canon drive. Canon 5501. I suppose I could look that up and let you know. I might actually set this to something halfway sane, even though it's going to disappear by the time I reboot the machine. Page up and page down to modify. I've run into that trick a couple times. I'm so used to pushing plus and minus on the number pad. Doesn't work here. Of course, it is December 10th. Oh, and you also can't put in numbers. It won't let you do that. You have to do it this way. Looks as though it would accept post-2000 date codes, although I don't know if it's like the Phoenix BIOS-based Zenith 486 is, and when you do that, the system complains that its CMOS RAM is bad, which is a very odd complaint. It is 2038. Now, for a hard drive. Now, this is a little bit different. This is not auto-detect. This is way before the days of auto-detect. And this drive is also way before the days of having the cylinders, heads, and sectors, or the CHS parameters, printed straight on the drive. So I'm going to have to look this up. Okay, I believe there is actually a drive type that corresponds to this. I might see if I can find it. It is a 40 megabyte drive. 43 megabytes would certainly be close, but that's not correct. 41 is closer still, but again, that's not correct. Those parameters do not correspond. You can see these parameters here. They do not correspond with what's actually going on with regards to the drive parameters. So yeah, it looks like I am going to be entering this in manually. So I've got to go to... No, it's not that one either. That one's close. Hold on just a second. Is that actually it? No, it's not. No. That's closer still. Type 40. What if it would actually tell me what the drive type is? No, it does not. I just have the CHS parameters. I'll just put it in manually. We'll put it in 47 as a user type. There were some systems that would not let you put in a user type for the drive. You had to know what the drive type was, and that might make something like this a little bit difficult. But it's been a long time since I came into contact with one of those. Okay, 820 cylinders. 6 heads. No write precompensation, which on this board is put in as 65535. Landing zone is usually the last sector, but in this case, the official specifications say landing zone of 910. So that's what I'll put in. Put it in correctly, which is there. And 17 sectors per track for a 41 megabyte size, which is accurate. We don't have a drive D. Primary display claims it's not installed. That's not true. Oops, forgot about that. VGA. Keyboard, we'll set that to installed. Scratch RAM option. If required, BIOS will use 256 bytes of RAM for option 1, using the stack area at blah, or 2, reducing base memory size by 1 kilobyte. Obviously, option number 1 is what it defaults to, and that's really the desirable option. See up here, 640K of base memory, that's your conventional memory, that's what DOS and most anything else loads into, and we have 384K of extended memory. Again, I'm simplifying things a little bit here, just for the crowd, and I don't know the details, so I probably should abstract a little bit so I don't say something wrong, and then have the die-hard aficionados come at me and say, "You're wrong, you moron!" And the numeric processor, of course, is not installed. That would be the math coprocessor. So we'll hit escape to exit. We'll write these changes to the Cmos. Push Y. And the system will reboot. See the very slow memory test. That sounded normal for the floppy drive. Of course, there's nothing on the hard drive. Let's see if it will actually boot to a floppy. Now, I hope that it's not going to wreck my floppy. Let's say a 1.2 megabyte floppy drive. So we'll take our, this is actually a 360K floppy, double-sided, double density, not a high density disk. We'll look at it, give it a precursor inspection, looks okay. We'll put it inside. Alright, let's give this a shot. Aha! It works. IBM Personal Computer DOS version of 3.2. It's fairly old school. I noticed with great curiosity that the activity light is orange. So there's a couple of things on here. I don't believe we've got something like MSD or anything like that. This would predate that. I've got format. I could format the primary drive or an F disk or something like that. Let's try it. Maybe I'll even try and put DOS on this machine. F disk options. Create DOS partition, delete, let's display partition data. Nope. No partitions defined. Let's go and create DOS partition. Do you want to use the entire fixed disk? Yes. System will now restart. Insert DOS disk in drive A. Oops. Yeah, so this floppy drive is definitely not the best. Oh yeah. Missing operating system. Let's do a full Control-Alt-Delete. Floppy drive has definitely gone back to not working. So, okay, well, it was fun while it lasted, I guess. We'll have to replace this floppy drive if I intend on really doing much of anything with this system. Yeah, still looks like my disk is okay. Which is all that I really care about. So we did that. We'll go ahead and I'll Control-Alt-Delete. We'll at least do something useful. We'll push delete. And we'll run diagnostics. So, on really old systems, you had to have a DOS boot disk, such as this, with the debug command on it. and you had to go to a memory address. On this, it's very nice for you. You get your low-level format tools right here. There's your primary hard disk format. There is a detect and it says detect and pre-format with optimum interleave, which used to matter. Again, the details escape me. There's a media analysis to locate and mark bad sectors. Performance test, let's go ahead and run that. So you can see here, drive C, disk type 47. It'll ask us for the specifications. Good enough. And then it'll ask us if we wish to proceed. And we'll type yes. Might be able to hear it there in the background. And there's a seek test. This is a really fun one. Then we'll put in all the details. Doing sequential right now. And you might be able to hear it. Hard drive light basically mimics that's on there, which is a green light behind a red bezel. This bezel actually came off of the ST225 that happened to stop working. This isn't the fun part. Have a listen to this. And it finally gets to the end cylinder. Alright, I'm not going to let that run forever. It won't run forever. It does actually stop at some point, but that's basically a random seek. Read, verify. I'll ignore that. Check test cylinder. That will be your highest cylinder, and we can force bad sectors. Prepare a list of tracks to be marked as bad. So that would be for entering in your defect map, which I'm sure some people have probably wondered about as well. If you wondered what that list of cylinders, heads, and sectors on the top of the drive is, that was a defect map. That was all your bad sectors. What you were supposed to do is, as they were found, you would write them on the top of that defect map. In practice, nobody ever really did that. You have floppy tests. I'm not going to bother with any of those because the floppy drive seems to be intermittent. Keyboard. You go ahead here and we can have a look at our keyboard where all the keys go. The layout isn't exactly perfect because this is for an AT layout, which is obviously not what we have. But all the keys do work, I believe, except for one. That one doesn't do anything. Scroll and lock, pause. Basically, this is just an excuse for me to type on the Model M keyboard. There is one key in the upper corner that it looks like it can't actually recognize, but everything else is pretty well recognized just fine. Of course, matching the layout of what would have been a typical AT keyboard at the time. I believe that would have been, what, an 84-key keyboard? Pretty sure that's an 84-key keyboard, though. Press Control Break to exit. That would be Control Pause. But of course, break is written there as well, because that's what it does. Video, here's some fun things. Run all the tests. Let's just go ahead and run them all. We can see there's a sync test, although it tells us that it's currently not implemented. A Adapter test, that's for the display memory. Attribute, check the attributes of the display adapter. 80 by 25 text test. 40 by 25 text test. 320 by 200 graphics. 640 by 200 graphics. Page selection and color. Let's just go ahead and run them all. That's the memory test. It's in 40 column mode, by the way. Or 40 by 25. Here's the next test. Reverse video intensified. So you can see it is detecting it as color, because that's what it is. But the BIOS is only in black and white, and I believe that's by design. There's 80 column text mode, that's the character set, part of the character set. There's the other part of the character set. 40 column text mode, which doesn't appear very well on this monitor. It'd be better on a CRT. 9 by 13. Scroll up. Scroll down. It does actually scroll if you saw that. And let's draw in colors. 320 by 200 graphics. Filling the screen pixel by pixel very slowly, because of course that's the best that it can do. This is very exciting stuff. Now we're going to 640 by 200, which is unfortunately only in black and white. Again, on a CRT monitor, this would look a lot less blocky and stretched. Or, sorry, not stretched, but squished. That's just a byproduct of the fact that I'm using an LCD monitor. Now there's a page test. Colors. The brown looks very orange. I'm not sure if you can tell. Trying to go a little bit slower so that I don't trigger any epileptic reactions. Border color, well, we can't really see it because this display, well, now we can. Maybe you can see it a little bit better. I'll have to readjust it when I go back to the this, which is where we are now. Still not quite perfect. I don't believe there are any other tests that I can run. I mean, I could test the printer port, I could test the communications port, that'd be the serial port, but there's really no reason to do that, so that's pretty much it. And we can see some system information. And I don't believe there's anything else that I can think of to show you, so that was a fairly long video about what is probably not exactly the most interesting of the 286 systems that was ever produced. See if I can get it to boot on this floppy one more time. I don't think so. It doesn't really sound that good. Let me make sure that didn't just trash my disk. Alright, let's try it. It doesn't really sound that healthy if you listen to that. Yeah, it's not able to read that disk at this point. So, there probably is a trick to getting this disk out. Just that I don't know what it is. I'm going to have to replace that floppy drive. Unfortunately, they seem to be fairly expensive if you look on eBay. So, I don't know, maybe I'll just fit a 3.5-inch floppy drive to this thing and call that one good and get a 5.25-inch one for a later time. But, speaking of a later time, I think we're going to do the rest of this on this system at a later time as well. Thank you for watching. If you have any comments, feel free to leave them down below. And this is CP666 signing off. I hope to see you next time. Till then, have a listen to that hard drive when we shut the system down. That's the auto parking in action, if you wondered. I'm hopeful that you will allow me something of a postscript on this already very long video, but I forgot two very important things. The first of which you can see readily right now. I didn't run the system with the cover on, so we could hear what it sounded like. So let's go ahead and do that. And in the process, I'm going to show you how I know that this turbo switch is reversed. I'll turn it on here. Let it come on. We'll switch off turbo. See how slow that became? You'll also note the turbo light turns off when I do this. The system also does not retain its Cmos settings for very long after the power is turned off. You'll notice we've gone right back to the default. And I noticed that it's changed to 640K 5.25-inch floppy drive. No idea where I come up with some of the things that I say in my videos. I'll have a listen to the drive with the cover on. Of course, it's not really going to sound much different because there's a gaping hole up here and there's an even gapier hole right there. Let's go ahead and run our seek test once again. It is a little bit quieter, at least. I don't know if you toggle turbo while this is going on. I've experimented with this a little bit. If you turn off turbo, or toggle the turbo setting, it will cause this test to crash the hard drive controller in a very interesting way. It will just stop. Drive light will be on constant. You might be able to see that it's green light there. You can definitely see the green in front of the red. It's actually more of an orange light because it's got the green going through it. I'm not going to sit here and run this whole thing, of course. And that is it for the video. Very long video. I do apologize. It'll be very nice when I get an actual working 5.25-inch floppy drive in this machine, though. But until then, that is actually it for the video.